So in our first section, we will look at our calculations with respect to whole numbers, fractions, and decimals. So to start us off, let's first have a look at our operations on whole numbers. So operations on whole numbers. So this is your standard uh, calculations that you're familiar with. So that's your adding, subtracting, multiplication, and division. So just a recap on those concepts, just since the fact that you aren't allowed to use a calculator in this exam, so you'd have to pick up and remember these manual processes, you can say it like that. So firstly, let's start off with our addition. So just look at an example for addition here. So for example, if you were given an example part of the question where 687 plus 45, so essentially you would have to put these in the columns of and break them up according to your hundreds, tens, and units. So here, just to manually add this if you aren't given, since you aren't allowed a calculator, and as well as if you can't actually work these things out in your head. So here, your hundreds, tens, and units, and then 687 plus 45, and then there we go. So firstly, 7 plus 5, so you start off with the units. 7 plus 5, that's 12. Then carry the 1. 8 plus 4 plus 1, so that would be 13. So 3, carry the 1, and then it would just be 6 plus 1, which is 7. And that is how you get your answer of 732. So as you can see here, each time whenever something exceeded 10, each time that one or that additional extra, that one was carried over into the next column. So that is how what we would do with addition. Let's look at some subtraction. So very similar subtraction techniques. So for subtraction, let's have a look at an example. So if you were to say, for example, 734 minus 45. So again, putting it in our columns of hundreds, tens, and units. 734 and 45. And now again, so this is slightly similar problem where, as you can see, if we subtract them now, we'll go down again as we would. So 4 can't minus 5, so we would need to take 1 from the tens column, so make that 2, and this would become 14. Right, so 14, so we borrowed 10 from the tens column, so 14 minus 5, that's 9, and then again 2 can't minus 4, so we'll borrow again a 10. We'll borrow from the hundreds column here, so that becomes 6, and that becomes 12. 12 minus 4, that's 8, and we left with 689. So whenever you have something that's less than 0, so 4 minus 5 less than 0, you would have to borrow or take 1 from the tens column or take 100 from the hundreds column in order to subtract that specific number at the bottom. So if this is how you would do, you can say, long subtraction. And another way to do this, if it's maybe numbers that are closer together, so for example, just to add a second example for subtraction, let's say, for example, 104 minus 99. You can look at this from a number point. So if you were to look at like a number line, for example, so a number line having that you have your 104 here, you have 103, you have 102, 101, 100, and 99. So just have 1 on either side. And basically, this is the point that we are looking at. So what we need to do is, if we find the difference between 99 and 104, it would take 5 steps. For example, here, if you to just count the steps, so this would be 1, 2, 3, 4, 5. So if you were to go from 99 to 104, So apart from that, then we can see it would always be adding 1 to the actual number of steps. So in this instance here, 104 minus 99 is actually, it's actually equal to the number of steps. Yeah, sorry. So that's 1, 2, 3, 4, 5. So that is equal to the number of steps, as we can see there, to just confirm. So that's an alternative method of subtraction by just looking at the number line if those numbers are actually closer together, as opposed to the previous one. But either or, the long way would work either for either one of these, whether it's close together or not. So that is subtraction. So if we move on to method of multiplication, so we look at long multiplication. So this is aside from your multiplication tables that you would essentially have learned throughout your primary and high school career. So here, if you look at a worked example, let's say 13 times 54. That's obviously, this is not your standard one, and this is where you have to use your columns against the 13 times 54, right? And as we would here, we would say, and we would multiply the top two numbers by the unit. So we would first start off with 4. So we'd say 3 times 4, then 1 times 4. Alright, so first we'll calculate 13 times 4, and then after that we would sort out the 5. So firstly, this would be 3 times 4, that's 12. And since we put 2 in the units column, and then we'd carry the 1, alright. So here in this instance, we will get 1 times 4, so we just put the 1 there just to remember. And 1 times 4, that's 4 plus the 1, that is 5. Now what happens now is, once we've done that first row, once we're done with the units part, we put a 0 in the units part now, because why? We are multiplying the 5, because the 5 is part of the tens. All right, so here we would say 3 times 5, that's 15. Carry the 1, so we just carry the 1 here. Let's just do that. Yeah, 1 here. And then we'll say 1 times 5, that's 5 plus 1, that is 6. And therefore that's how we get 650 for that row. And now we are going to add going downwards. So then we'd say 2 plus 0, that's 2. 5 plus 5, that's 10. So 0, carry the 1. 1 plus 6, that is 7. So that gives us 702. So just a recap on these methods and techniques we might have forgotten about, since we are so dependent on the calculator. Right, so that is multiplication. Then moving on to division. So dividing now, this is your long division that comes into play here. So for example, if you look at a quick example, yeah, 192 divided by 3. So here 192 would go inside the division block, and 3 would go on the outside, and then that's where you would start. So based on the acronym of daddy, mommy, sister, brother, so division first. So 3 can't go into 1, so we would carry the 1 over to the 9. So 3 goes into 19 6 times 3, that's 18. So that's your multiplication done. And then subtraction, 19 minus 18, that's 1. And then B is for bring down, so we would bring down the 2. So that whole process again. So division, 3 goes into 19 6 times. Multiplication, 6 times 3 is 18. Subtraction, 19 minus 18 is 1. And then bring down the 2. So again, start the process again. 3 goes into 12 4 times. 4 times 3 is 12. And 12 minus 12 is 0. And there's nothing to bring down, so we stop right there. So in this instance, it tells us that 192 divided by 3 is 64 with no remainder. So 3 goes exactly into 192 64 times. Another thing when it comes to division is when potentially, if you think about a sweet situation where, for example, if you have 12 sweets and you put them into packets, or maybe they give you a certain number of sweets, and they say, okay, how do you divide essentially 12 sweets equally between 3 friends? So that essentially is 12 divided by 3, and then therefore each each friend will be given 4 sweets. So just those type of situations and scenarios you would need to be aware of. Right. One more thing in terms of the multiplication and division scenario is concept called approximation. So just something that could potentially help you as well. It's like maybe you're running out of time, or if you're unsure on how to get your specific answer. So maybe also useful to do this approximation maybe just even before you're doing your calculation, just so you know you in that specific ballpark. So for example, if we look at 48 times 103, and so what we would essentially do here for approximation, we would round off 48 to 50. So this would get rounded off to 50, and 103 would get rounded off to 100. So therefore, we would say 50 times 100, which is essentially 5,000, is approximately or will be very close to what 5 or to what 48 times 103 is, which is in fact 49. So just to add this answer here, which you, if you were to work this out using your calculator or whatever, just to confirm, as you can see, our approximation is more or less in that same ballpark there. So 550 times 100, which is 5,000, is very close to what 48 times 103 would be. And likewise, you can do the same thing for a division situation. So for example, if you were to take 25116 divided by 483, and therefore if we were to round these values up or down for that matter, this would be 25,000 divided by 500. Right, so the 25,116 rounded down to 25,000, and 483 rounded up to 500. So here we can approximate that answer to be 25,000 divided by 500, which gives us 50. And as you can check there, I'm sure we should get an answer very close to 50 of that original answer. So as a whole, these are your operations when it comes to whole numbers. And so now moving on to fractions. So fractions is our next thing we need to be aware of, part of this specific subsection here. So fractions here, so just a brief recap. If you have 3/4, this is your numerator, number on the top, and the number at the bottom is your denominator. So apart from that is you also have different types of fractions, so you'd also have to know how to simplify fractions. So here, if you are potentially given some sort of for example, if you have say 12/6, as you can see, this isn't in its simplest form. Let's just use a one that's less than 1. Actually, let's say 6/12. As you can see, you would have to divide the top by 6, divide the bottom by 6, and then you would get 1/2. So understanding how to simplify or equivalent fractions, because 6/12 is equivalent or is equal to 1/2. So simplification in that point of view as well. Apart from that, you also get improper and mixed fractions. So here you get improper, and you also get mixed fractions. So your improper fraction is generally a number that's in a fraction form that is more than 1. So for example, you'll get 7/4. So generally when the numerator is bigger than the denominator, and generally it's best to keep it in improper form, or depending on the situation. So what this basically essentially is telling you is that 7/4 is 7/4, so there are 7 quarter pieces. So here that basically tells you, okay, that you have one whole and then three other quarters, right? And then another a mixed number on the other hand, if you need to convert this into a mixed number, so that would be 1 and 3/4. So this is made up of a whole number. So here, just an improper fraction, this is when you can say the number or the fraction is greater than 1, and then a mixed number consists of a whole number and then a fraction next to it that is less than 1. Yes. than 1. And if you were to convert a mixed fraction to an improper fraction, because that's generally the better way to represent it. So if you were to have 1 and 2 over 5, the way to do this would be to multiply that denominator and the whole number, and then add the numerator. So here this would be 1 times 5, which is 5, plus 2 all over that original denominator. So this would essentially be 7 over 5. And likewise, if you were to go back, for example, let's just use an example like 12 over, let's say, 5, for example. You would see how many times does the denominator go into the numerator. So that would be 5 going into 12 2 times. And then that's your whole number. And then the balance, which is 2. And then that would just be 2 over 5. So that's in terms of fractions. And we will go into adding and subtracting. So here, adding and subtracting fractions.